Hi everyone, my name is Raven Gleyo, and today we are going to talk about the acceleration, no speed. So the objectives for today is that measure the acceleration of a moving object based on its position as time increases. Second is find the t average and the t average squared and make a graph. So materials needed is that linear air truck, 260 GM weights, millisecond timer, and a graph paper. So as you can see, this is the experimental setup, and this is the data and results, the predefined findings from the experimental setup video, as well as the computed time average and time average squared are shown in the table below. In accordance with this, the slope of the graphs is calculated using the formula change in position over change in time, and its acceleration is calculated by multiplying the acquired value of slope by 2. So let's move on to the graphs of table 1 and 2. These are the straight line graphs, as you can see, of the black wide side down data. And this is the graph of table 3 and 4. These are the straight line graphs of the black narrow side down data. For data analysis, as demonstrated in the video, the position of the air track might impact the outcome of the experiment. The air track should therefore be balanced since the glider tends to glitch to the right or to the left side of the air track. In addition, the glider should be launched with a full blow to get a consistent results. When I first plotted the point, this is where I experienced challenges when producing the graph. I had difficulty reading the table since I had been careful where to put it, and also my x and y axes were interchanged while entering the value. Third one is the data is not statistically different. However, the width and the thin side differ. As you can see in the graph, the time spent on the black wide side down for every distance is lower than the time spent on the black narrow side down for every distance. As observed in the various layout, both accelerations are unique. The narrow side down data has a far higher speed than the large side down data, which have a meter of 0.095 slope and 0.19 meters per second squared acceleration. The amount of the glider acceleration will be linked with the gravity if the air path is tilted nearly vertical or perpendicular to the floor. This is the recommendations in conclusions. The experiment proved effective in determining the moving object's accelerations based on its position as the time continued to grow. You can then use the equations change the position or time for the slide, and a 2m is equal to acceleration using the position and time graph to determine the path and the speed of the cart at last. These are the values for block wide side down. The slope is 0.3793 and the acceleration is 0.7586 meters per second squared. While for the block narrow side down, the slope is 0.095 and the acceleration is 0.19. As a result, the block wide side down accelerates more, while the block narrow side down accelerates less. Thank you for listening.